All right, so you've sent over a bunch of readings on data science. Looks like you're really interested in how that structured data in relational databases, the kind you work with all the time, can be used to build these predictive models. Pretty cool, right?
What's cool is that we always think about databases as just storing info. But the real magic is when you use it to, well, predict stuff, future behavior, like having a crystal ball, but it's in your data.
Yeah, exactly. But you have to be careful. There are some things to watch out for, like overfitting. That's where your model gets a bit too comfy with the data it's trained on.
Right.
And then it doesn't do so well with new info. Kind of like when you just cram practice questions before an exam.
Yeah, totally.
Bank on the real thing.
Exactly. Okay, so let's say we want to predict customer churn, which customers might leave. This is like supervised learning, right?
Right.
We're feeding the model data on customers who left and those who stayed.
Exactly. You got it.
And it's super important to have data on both types of customers, right? The ones who churned and those who didn't. Yeah, you need both. You have to show the model the full picture. Otherwise, it's like trying to learn a language only from textbooks without ever hearing it spoken.
Makes sense. So then how do we pick the right features from the database for our model? I mean, there's so many columns, right?
Right. That's where informative attributes come in. Like which attributes are most related to what we're trying to predict. And algorithms like tree induction use this idea of entropy and information gain. It helps figure out which attributes are the most valuable, the most predictive.
Okay. So for customer churn, maybe we'd look at things like purchase history or how often they contact customer support, right? But how do we actually measure which of those things are the most informative?
Okay, so imagine this. You've got a data set, bunch of customers, some churned, some didn't.
Right.
If it's all mixed up, you've got high entropy, a lot of disorder.
Okay, lots of chaos.
Right. But now let's say we look at number of customer support calls. If we separate customers based on that, and we get groups where, like, one group has mostly churned customers and the other mostly hasn't, that means number of calls has high information gain.
Ah, I see. It helped us organize the data in a way that's useful for predicting churn. Less chaos.
You got it. So algorithms like tree induction, they build a decision tree. Basically a set of rules based on these informative attributes that lead to a prediction, will they churn or not?
So like a flow chart.
Yeah, like a flow chart.
Okay, that's tree induction.
Yeah.
But you also mentioned logistic regression, right?
Yeah.
What's the difference?
So tree induction is all about rules, right? Logistic regression uses a mathematical function to calculate the probability of something happening, like churn. It looks at all those attributes we picked and gives them weights based on how important they are for predicting the outcome.
So logistic regression gives you a formula that uses all those weighted attributes to estimate the chances of someone churning.
Yep, exactly.
It sounds like both tree induction and logistic regression have their pros and cons. How do you decide which one to use?
That's a great question. It really depends on your specific data and what you are trying to do. Sometimes you might even try both and see which one performs better. But before we jump into comparing different models, I want to talk about a different way to look at the data, thinking about similarity, neighbors, and clusters.
Okay, I'm intrigued. That sounds like a whole other approach.
Instead of trying to predict something like churn right away, what if we first try to see how our customers are naturally grouped? That's where clustering comes in, grouping customers who are similar based on their attributes.
So instead of will they churn, we're asking who are they most like?
Exactly. It's like finding the different tribes in your customer base. And this can be super helpful, for understanding your customers better, maybe making your marketing more personalized, or even creating new products for those specific groups.
So how do we actually find those tribes? I mean, it sounds kind of hard to look through all that data and figure out who belongs with who.
Right. So that's where clustering algorithms come in. They use all that customer data, all those attributes, and then they group customers into clusters. People within a cluster are more similar to each other than those in other clusters.
It's like a sorting hat, but for customers.
Exactly. But how do we measure similarity when we're talking about data in a database?
Well, there are different ways, but one common one is using distance. Like, imagine each customer is a point in space, and each dimension is an attribute.
Okay, so plotting customers on a map, kinda.
Yeah, kinda. And the closer 2 points are on this map, the more similar they are. And that's where clustering algorithms come in and try to find these natural groups on this map.
So we're basically making it a map of all our customers and then circling groups of customers who are alike.
Exactly. And once we've got those clusters, we can start to analyze them. What makes each cluster different? What are their preferences? This is super helpful for making better decisions.
This is all really cool, but how do we know how many clusters to look for? Is there a magic number or something? That's a great question. And it's actually one of the tough parts of clustering. There isn't one right answer. It depends on the problem and the data. There are some techniques to help you, like the elbow method and silhouette analysis. They can help you see which number of clusters works best for your data. But let's switch gears for a second. Let's talk about another really cool technique that uses this idea of similarity.
Okay, lead the way. I'm ready for more.
Okay, imagine you've got a new customer, and you want to predict if they're going to churn, right? So instead of building some complex model, you could look at what happened with customers who are most similar to them in your database. We call this nearest neighbor reasoning.
Oh, so it's like asking their data doppelgangers, did you churn? And using that to make a prediction. It sounds almost too simple.
It might sound simple, but you'd be surprised how well it works, especially when you have lots of data and a good way to measure similarity. This is used a lot in like recommendation systems, when you get those suggestions for things you might like.
Ah, right. So if I like certain books, the system finds other people who like those same books and suggests things they liked that I haven't read yet.
Exactly. It's all about finding those nearest neighbors in all that data.
This is making me think about my database in a whole new way. We've covered so much, from predicting churn to finding hidden relationships in our data. It's like we're seeing all this hidden potential in our database.
Absolutely. And honestly, we've only just started. There's a lot more to explore in data science and how to use it with your relational database. Have you ever thought about using your data to not just predict what might happen, but to understand why it's happening?
Now that you mention it, that would be a whole other level of understanding.
It is, and that takes us to something called causal inference, where we use data to figure out the cause and effect relationships driving what we're seeing. And well, that's what we'll be diving into in the next part of our deep dive. Welcome back. So like we were saying, it's all about getting to those data-driven causal explanations. It's not just about predicting what'll happen. It's about understanding the why, right?
It's like being a data detective.
Yeah.
We're not just looking at clues. We're trying to put them all together, figure out why things are happening in our database.
Yeah.
It sounds really powerful, but maybe also a bit complicated.
Yeah, it can be. But let's start simple. Imagine you have a database, all your customer purchases, and you launch, say, a loyalty program. You see sales go up afterwards. But how do you know if the program actually caused that? Or was it just a coincidence?
Yeah, just because things happen together doesn't mean one caused the other. There could be, other reasons. The economy's doing well, or maybe a competitor went out of business. So how do we know it was really the loyalty program?
One way is A/B testing. You randomly put your customers into two groups. One group gets the loyalty program. That's like the treatment group. The other group doesn't, the control group. Then you see how each group behaves, like their buying patterns, over time.
So it's like a science experiment, but with our customer database. And by looking at both groups, we can see if the loyalty program really made a difference.
Yeah, exactly. But sometimes A/B testing isn't possible. You can't randomly make customers churn. So in those cases, we can use causal modeling.
Causal modeling. Sounds intense. What's the idea there?
It's basically making a visual model of those cause and effect relationships between all those different variables in our database. These models, we call them directed acyclic graphs. They use arrows to show the direction of cause and effect, creating a flow chart of how different things might be affecting each other.
Okay, so an arrow from, say, number of customer support calls to churn rate, showing that maybe those are connected, one causes the other. But how do we know the arrows are pointing the right way? What if it's the other way around? People who are already planning to churn are calling support more.
That's a great point. That's why it's so important to really think about the relationships between the variables and understand how things actually work in the real world.
Yeah.
You're not just drawing arrows, you're using your knowledge to create a model that makes sense.
So it sounds like you need both the data science and the real world experience to build a good model.
Yeah.
But once you have one, what can you do with it?
That's where things get really cool. These causal models let you go beyond just seeing correlations. You can start to ask those what-if questions, like, what if we offer a discount? How would that impact customer retention, even if we haven't actually tried that in real life?
Wow, that's pretty powerful. Having a simulator for your business, you can test different things out and see what happens.
Exactly. And being able to see those different scenarios, understand how your actions might play out, that's what makes causal modeling so powerful for making decisions.
Yeah, I'm seeing that now. We've talked about predicting things and finding hidden patterns, but now we're talking about the why. That's a whole other level of insight.
Right. And understanding those whys helps you make better decisions. Like if your model says that long wait times for customer support are making people churn, then you can focus on fixing that, right? Improve your response times.
It's like we're moving from just reacting to things to actually getting ahead of them. This is exciting.
It is exciting. It's one of the many ways data science can really unlock what's hiding in your database. But even with all these amazing techniques, we have to remember they're not perfect. There are limitations, and we got to use our data responsibly.
Right. With great power comes great responsibility.
Mm-hmm.
Right. What are some things we need to keep in mind as we, get deeper into all this?
Well, first, no model is perfect. There's always going to be some uncertainty, so we got to remember that when making decisions based on those models. And we have to watch out for biases in the data or the models themselves. Like if your historical data reflects, say, some unfairness, then those biases can show up in your predictions.
So it's not just about building fancy models. It's about using them carefully and ethically.
Exactly. Data science is powerful, but it's on us to use it the right way. We need to be open about how we're doing things, be careful about how we understand the results, and always think about how our decisions will affect people.
This has been really eye-opening. I used to think about my database as just a place to store info. Now I see it's like this dynamic source of insights and possibilities.
That's what we want to show you. Your database is full of valuable information just waiting to be discovered. And with the right tools and approaches, you can turn that data into knowledge and use it to make better choices, better outcomes.
Okay, before we go too far, let's take a minute to go over what we've learned so far. And then maybe we can talk about some practical tips for actually using these ideas with real databases. Okay, so we've been talking about all these cool data science techniques, but what if you don't have tons of data? Does that limit what you can do?
That's a great question, and it's actually really common. You'd be surprised what you can do, even with just a little bit of data. You just got to get a little creative, think outside the box.
Okay, so how do you make the most out of a small data set? Are there any special tricks?
One thing you can do is called data augmentation. Let's say you're working with images, like pictures of products in your database.
Right.
You can actually create more images by, flipping them, rotating them, or cropping them differently.
So you're basically making copies of your data,
Yeah.
but with little changes.
Yeah, exactly. But it's more than just making copies. You're showing the model the same data from different angles. And that can help it learn better, even with less data.
So it's like showing the model different sides of the same thing, so it gets a more complete picture. What else can you do when you don't have a lot of data?
There's also transfer learning. It's basically using knowledge from one problem to help solve a different but similar problem. Like, if you learn something in physics, you might be able to use that to understand something in chemistry.
Right, okay. But how does that work with data?
Let's say you want to categorize customer feedback in your database, but you only have a few examples. With transfer learning, you can use a model that's already been trained on a ton of text from the internet, and then you just fine-tune it with your smaller data set.
Oh, I see. So you're giving the model a head start. It's already learned some general stuff from all that other text, and now it just needs a little extra training.
Exactly. It's like having a tutor who already knows a lot and can help you learn faster. This has worked really well with things like understanding language and recognizing images.
This is really cool. It sounds like even with a little bit of data, there's still a lot you can do. But with all this talk about algorithms and stuff, we haven't really talked about the human side of data science. What about our judgment and intuition? What role do those play?
That's super important. Data science isn't just about blindly using algorithms. It's about using them to help us, to extend our own intelligence. Our intuition and experience are key for asking the right questions, understanding the results, and making good decisions.
So it's like a team effort. Humans and machines working together.
Exactly. The best data scientists are the ones who can combine those technical skills with their own thinking and creativity. They use the tools to help them make better judgments.
That makes sense. It's not about replacing humans. It's about making us better.
Right. And as data science keeps evolving, that balance is going to become even more important.
This has been an amazing journey. We've talked about so much. Predicting things, finding hidden patterns, the why behind it all, the challenges of limited data, and how our own judgment fits into all of this. I feel like I've learned so much about how data science can help us understand things better and make smarter choices.
It's been great talking with you. And remember, data science is always changing, but the ideas we've talked about today are the foundation. They'll always be important.
And to everyone listening, thanks for joining us on this deep dive into data science. We hope you've learned something new, that you're feeling inspired, and that you're excited to see what you can do with your own data. Until next time, keep exploring, keep learning, and keep asking those great questions.